Okay, AP Physics, UT Quest problem in fluid statics. This is a balloon with the payload. What often throws students here is there is a detractor. There's more information here than what you need. Okay, let's take a look at our free body diagram. This first part is very simple. We're given the mass of the payload and the empty balloon. That's given, just multiply it by g, and that gives us a downward force. Now here's part of the tricky part, right here. Right here we have another weight, and that is a weight due to the gases inside the balloon. Those gases, even though you say they're lighter than air, that still does not mean that they do not have mass and they do not have weight. It just so happens the weight is less than the buoyant force, so it tries to float upward. But still, we have to consider that weight of the gases inside the balloon. So I have two weight vectors acting down, and I can get this weight of the gases by the density of the helium-air mixture times the volume of the balloon times g. That's our two forces acting down. Counterbalanced by our buoyancy force acting up. Okay, the balloon is immersed in air, air displaced by the volume of the balloon times g. Okay, so now we set up a force equilibrium problem. We've got our two forces, our two weights acting down. We have everything to calculate that. We have our weight of our gases in the balloon in terms of volume, and we have our buoyant force in terms of volume. So all we have to do is substitute in our terms for each one of these three things and solve for the volume of the balloon. Okay, now what about this helium density? What do I use that for? And the answer is absolutely nothing. Not a player. Because what's inside of the balloon is a mixture. So you're going to use that mixture of helium and air density to solve for the weight of the gases.